Hello. In this video I recap a little bit of the big changes that were lately committed to this project. This is Tripscode, and I renewed and reviewed and refactored those subdivision systems there in my program. And let's check out this is about the subdivisions, and I can subdivide objects now with different levels, but before it was the only single subdivision level for the session, and you can then with page up and page down change this level. But now I can constrain this subdivision level for individual objects. And here in GitHub I have this subdivision system update, and this was very extensive because I had already prepared for this sort of change, but I haven't implemented it, and I merged some functions into single function in poly rendering, for instance, where rendering took place based on the subdivision happening or not. And without subdivision, the subdivision level is -1, and starting with 0, subdivision levels increase. And we can quickly check out how many changes there were, and it was very extensive, those changes, because this is very sensitive. You can miss some little thing and the whole system collapses. And it also executes all those drawing arrays in the OpenGL also. That's why it's so difficult. For instance, here in curves header file, I have updated curves subdividing because curves need to subdivide along with the objects that they belong to. As soon as they start to subdivide independently, then the connection between object and those subdivided segments stops to execute, and then you have unwanted results. For instance, for curves, but the main big changes were in rendering, since all the drawing routines were reviewed and merged into single functions, many those drawing routines, and it is a lot of changes here. The change paradigm was simple. It checks beforehand if submitted the subdivision level equals to -1, and if it equals, then it takes action based on the individual objects. But if it's not for object level -1, then it creates higher connections in the system. And here we can see it was a lot, and object got this new properties here. Sub level max was newly submitted. Later on it got also another important control variable, and it was let's check out where it was, allocation variable. So we see here in object structure allocated subd level is also used now, because this was the bug in my system beforehand. It was unnoticed, but when you user changed the subdivision level into higher level and then came back to low level and then again into higher level, then those higher levels were not reused but rather recreated, and that was a little miss there. So some memory went into junk with it. But now this allocated sublevel variable controls this, and the new again subdivided states are not allocated anymore if they already exist, and so on and so forth. Very many places were changed, and lately I changed this rendering system also to use this new paradigm that you can have various subdivision levels for various objects. And accidentally it doesn't work if some of the objects are at the unsubdivided state and some of the objects are in subdivided state. Then it takes this subdivided state and uses only subdivided objects to render. And then that being said, you still can subdivide an object to the level 0, and the rest of the objects can be same or the higher level, and then it still renders. And let's check out this rendering paradigm here. And I also keep this scene ready to demonstrate this rendering, but let's check out this code first. We see that in main file, when pressing F12, the rendering starts, and first it finds objects in the current view, then it finds a view, alright, and complicated stuff starts with this populate box 3D aim and deviation, and this means that elements like vertices are polygons and quads are equipped with aim vectors from current camera, so that when you start to render pixel by pixel, then you don't need to calculate for every pixel those vectors, but they are already for the current frame. And this was pretty interesting, and it also utilizes this unique concept in this program, the subdivision bounding box concept, because when you are subdividing, then those subdivided elements, for instance polygon quadrants or triangles inside those polygons, are found generally at the same spot than the same polygon. They are not necessarily in the same place, but they may in great probability lay in the same area, and that's why it uses this search mechanics to locate those elements inside the view. This way you can sort those elements quickly out that doesn't belong to this pixel. And let's check out this populate function here. Here it was also several changes to this function to avoid crashes for this system. And let's check out also this rendering function, render and save image. And this is a little bit funny because it uses parallel threading in the processor terms, but not it doesn't commit to the graphics card. And we see here it readies the image data and renders here render image, and we check this out. Here we see that this render image function starts those individual threads, and this num threads equals to 8 threads for this instance. And it creates those threads with this perform work function. And this perform work function is found here above it, and it uses this void paradigm to submit this return values and arguments. And we see here it starts to scan those pixels for the camera view, and we see some calculations here, and here we see that this deviation in the submitted subdivision level for L, if it equals -1, then it starts another function, and if there are subdivided level state, then it starts another variant of the function, and that's why they can't be mixed. But let's check out what happens inside this commit pixel function. We go into implementation, and we see here that first it starts counting objects, and then it starts polygroups counting inside the object. And those polygroups are essentially some gross divisions of the screen space, and this is the first step to optimize a renderer. Then we get, for instance, 16 subdivisions in the U, and those subdivisions then maybe are empty or consist only a few of the polygons. Then this makes calculations faster. And here we see that at every step when it goes further in the subdivisions, then it checks this subdivision. If an element is subdivided, then it goes into its subdivided elements. And this way it doesn't really check this L variable that is submitted, but it goes into this object rather. Maybe it uses this L also somewhere, but and what it does at every of those steps, it here says render pixel, and it checks with those deviations if a ray from the camera intersects the given element. And here it renders pixel, and when it's triangles, it renders triangles, let's check out this what this pixel means. This is the variant for the triangle rendering also. But if it's render triangles, then it's also similar thing. Triangle rendering is much elaborate, but what was the pixel rendering? Render pixel is what is you doing? Maybe the same thing, but it only I'm not certain about it. I wrote it a long time ago already. But let's check out how this works also. I prepared this scene, and we can see that the items now have this subdivision max variable here. And this can be also combo variable, that when we get more of the items selected, then we can change it in combination. But right now one as level 0 and the other as subdivision max 2. And I just press page up several times. And maybe it's no, it's enough. And I just execute this renderer here. I put this ready to demonstrate the rendering, and in the folder I delete this previous rendering. I delete it, and I press here F12, and we can see here that rendering has started. And this treated rendering, it renders in the processor treats, and now it says it has been saved, and here we see this this one. And when we observe this image, then we see this one. When you observe this, for instance, this neck area, this one is first subdivision level 0, and this one is 2 levels higher.